Bismillahirrahmanirrahim. My name is Munir Khan and I will give you a lecture about vector space. So let's start. First of all, what is vector space? A vector space V over a field F or a linear space mean it has an order of 1, consists of a set on which two operations addition and multiplication are defined, then it is called vector space. And we know the unique element xy in V and alpha belongs to F, which is element of field and vector space. In order to prove the vector space, it must hold the 8 properties of vector space. So let's start vs1 for all xy in V mean every element xy in V. If we add together x plus y is equal, then it must be equal to y plus x. If this hold, then commutative property is satisfied. And the second one is associative property of addition, means xyz in V, then it must be equal to x plus bracket y plus z bracket close. Third one is there exists an element in V denoted by 0 such that if we add every element x which is element of vector space in 0 plus 0, x plus 0 is equal to x for each x in V, then this property is satisfied. The fourth one is for each element x in V, which is inverse property. If we add x plus minus x, then it must give 0. Fifth one is x in for every element x in V, means if we multiply every element of vector space with 1, then it must be give the same result, same value x. Sixth is associative property of multiplication, and the seventh property is and every element alpha in F and xy in V, if we multiply with the addition of vector space elements, then it will give alpha x plus alpha y, and a similar like vs8. And the element of the field are called scalars and element of the vector space are called vectors. Don't be confused with these terms. It will be clear on you when we will do examples. So here is our first example. In this example, s is equal to a1 a2, which are element of real numbers, and let a1 a2 belongs to x, b1 b2 belongs to y. First we have to prove commutative property, which is x plus y is equal to y plus x. Addition is defined here, a1 plus b1, which is first element, and a2 minus b2 means subtract the second from first. So uh, multiplication is defined usually. First of all, a1 a2 plus b1 b2, a1 plus b1, a2 minus b2. It must be keep in mind that a2 minus b2 not equal to b2 minus a2, means first property not hold. If any one of the property is not satisfied, then it is not a vector space. Okay, let's move to the next example. Let f is equal to c and v is equal to c, where c is the set of complex numbers, and addition is defined usually, and the multiplication is defined by alpha dot x is equal to real element of alpha x. Is c is a vector space or not? So let's prove. First of all, commutative property satisfies easily if we take x1 plus iota y1 belongs to x and x2 plus iota y2 belongs to y. If we add x plus y, then x1 plus iota y1 plus x2 plus iota y2 x1 plus x2 plus iota y1 plus y2 means x1 plus x2 is equal to x2 plus x1. First property is satisfied. Similarly, associative property holds, and the third property is x plus 0, means if we add every element of vector space x1 plus iota y1 plus 0 plus iota 0, and a vector space is complex number here, so it gives the same value x. And the fourth property is inverse property is satisfied too. Fifth property is not satisfied here, because if we take just real values, then left hand side is not equal to right hand side, so it is not a vector space over C. That's all. In the next lecture we will discuss about subspaces and its properties. Like and subscribe my channel for more videos, and don't forget to click on the bell icon. Thank you.